Hello, ladies and gentlemen. Welcome back to math. A few concepts ago, we learned about exponents and variables and how those, when you combine variables, you have to either add those exponents if you're multiplying the variables, or if you're dividing the variables, you're supposed to divide or subtract the exponents, okay? Today, we're going to put it to the test. We're mostly just going to do the division ones because those are the ones you see the most, okay? So, bear with me, okay? All right. The example for today is 12p to the third, t to the second, r minus 21 p squared q t r squared minus 9 p to the third t r. Okay? All of that over 3p squared tr. Okay? You might ask yourself, Mr. Rivera, that's a very long problem. It's okay. What we're going to do is we're going to break it in pieces, okay, to make it a lot simpler. This is what we're going to do. Make sure it's written down, okay, first of all. If, in case you can't see down here, this little piece here is 9p to the third tr. Okay, that's a little r right there in the corner. Once you write it down, what we're going to do is we're going to break it down into 3 pieces. Okay? The reason why we're going to break it down into 3 pieces is because we're going to get each one of these sections. Okay? Notice that there is one section, and then the negative, another section, and then we have our negative 9 and the r as the third section. Okay? So we have 3 different sections. So we start off by doing the 12. Do it out here. 12 P3 T2 R, okay, over our bottom, which in this case is 3 P squared TR, okay? Then I'm going to keep the minus from the other equation. Minus 21 p squared q tr squared over, again, we're going to use the same one on the bottom, okay? 3p squared tr, okay? And then finally, we're going to do the third part with the same number on the bottom because the number 1 is being divided to all 3. So we have another minus 9 p to the third tr over 3 p to the third, or in this case second. I got a little bit excited. I added another one. So the second tr. Okay. Notice that we broke it down into 3 pieces. Okay. Now that we have it broken down, before you do anything, see if you can cancel out things. Things that are similar, okay, on both the top and the bottom. Makes it a lot easier for you guys. Okay. So notice that there's only one R on both. So we can cancel out the R. Cancel out the R, cancel it out. What about on this one? Is there anything they both have in common? They do. They have P2 and P2. So we're going to cancel out the P2. We're going to cancel out the P2. Notice that they also, one has a T, okay? And the other one has one T. So the T's are going to be canceled out. And then on the final one, notice that we have TR and TR that are exactly the same. So we're going to cancel them out. Now that we cancel those out, whatever we have left over, we're going to do it like a normal division, okay? Meaning, 3 can go into 12 how many times? Okay? Let's count them. So we have 3, that's 1. And then another 3, that's 6. That's 2. Another 3, that's 9. That's 3. And then another 3, that's 12, which is 4. So we got 4. 3 can go into 12 4 times. So we have 4. Notice that we have P3 and P2. If you guys remember from the previous, one of the previous videos, okay? When that happens, you subtract the exponents. So P3 minus 2. So 3 minus 2 is 1, or just P. P1. Or it can also be just P, okay? It's up to you guys. How you guys want to see it. Just keep in mind that when there's no P, it's a 1. Then we have T2 minus T. So T to the second power minus T. Okay? And it's not the kind of tea that you drink, but we're going to subtract 1 T from the square, which is just T. Okay? So now all of this became 4PT minus 3. Can 3 go into 21? Yes, it can. 7 times, right? So 7 times. Notice that we canceled out the P's. We have a Q on top that there's not a bottom, so we're just going to bring that Q down. And then we have R squared minus R, which in this case is just R, right? Because we subtract 1 R from R. So R. So all of these became 7QR. Minus the final one. Again, can 3 go into 9? Yes, it can. 3 times. So 3. P3 minus 2 is 1. And everything else was canceled out. So our final answer is 4PT minus 7QR minus 3P. Okay? You might ask yourself, Mr. Rivera, how come we can combine the 4PT and the 3P? Because notice that this one has a T, this one doesn't. They are not the same. Okay? So since nothing else can be combined, that is our answer. Okay? Make sure you write down everything on the board. Okay, I'm going to step out of the screen here for a little bit so you guys can pause it and write it down. All right, now that you have it on your notes, I know it was probably a lot of work. It was a few steps, okay? This is one type of division, okay? Next class, we're going to learn another type of division, which is long division. But for today, it's just normal division with polynomials. Make sure, okay, if you have any questions, let me know. Okay? So here is your assignment for today. Alright guys, your assignment for today is 18a squared plus 30a squared over 3a. Okay? So that's your first problem. Your second problem is 24 m n to the 6th minus 40m squared n to the 3rd over 4m squared n to the 3rd. Okay? Let's do this. Let's not do square for the m. Let's just keep it basic. Okay? So here's your problem for today. Make sure you submit your answers as soon as you're done watching the video. And I'll be waiting for your email.